All right, class, now I'm going to do the Chapter 5 outline, example number 4, that SAT once again with the TI Nspire calculator. And the first thing they want you to do is draw the picture. Just draw that normal distribution again. And it says, suppose a college says it admits only people with SAT verbal test scores among the top 10%. How high a score does it take to be eligible? Remember, our mean is 500. Our standard deviation is 100. Mean is 500. So that would be like 600, 700, like that. And remember, these are our z-scores down here. Z, -3, -2, 1, 0, 1, 2, 3. And what percentile will we be using? If you want to be in the top 10%, that means you beat 90% of people. That is the 90th percentile. Remember, percentile is the percentage of people that scored less than you. The 90th percentile would be 0.90 as a decimal. Because when you think of percentages in a calculator, they need to be in decimal form. So use the calculator to find the z-score. So remember, with z, your mu is actually 0. So normally it's 500 and 100, but the mu is 0 and the standard deviation is 1, like that. For normal numbers, it's 500 and 100, but for the z-score, you always use mu equals 0, standard deviation equals 1. So I'm going to go to my calculator, and once I get to my calculator, remember, we're doing like a reverse right here, where we know the percentage, we're trying to figure out the value. So I'm going to do menu, statistics, distributions, and not normal distribution, inverse normal, like that, inverse normal. So the area is the percentile. We want the 90th percentile, and it is mu is 0 and sigma is 1 for the z value. And I'm hit OK, and it's 1.28. Z equals 1.28155, like that. All right, so there's my z value. Now, to convert the z-score back to regular units, there's a couple of ways I can do that. I'm going to do it in the calculator here, because you'll have a calculator on the test, or you'll have Staplet. Now, I'm going to go menu, and stats again, and distributions, and inverse normal again, except this time I'm not doing it in terms of z, I'm doing it in terms of the actual score. The 500 is the average, and the standard deviation is 100. And we are the 90th percentile. And I get 628.155. 628.155. And remember, I can check to see if these match. Because remember, for the z-score formula, z should be equal to x minus mu, or x bar, over sigma, or s, right? And let's check and see if that works. See if both of these work. 1.28828.155 is equal to 628.155 minus 500 over 100, like that. Let's see if that works. So this, the top would be 128.155 over 100 equals 1.28155. And divide both sides. This just goes over 2 if you divide by 100, so you get 1.28155 equals. So it worked. It matched the z formula. So that converts the normal score into a z-score. So the correct answer is 628.155 with a z value of 1.28155. So that is the answer for number 4 of your Chapter 5 outline.